So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the Virtualization System topic for the subject computing. So first of all, we have to know what is Virtualization System. Virtualization support on the Windows-based platform. So then Linux kernel offers an abstraction layer to allow software processes that to work with it and operate on resources without knowing hardware details. New hardware may need a new Linux kernel to support. Therefore, different Linux platforms use patched kernels to provide special support for extended functionality. So we'll see with through the example. So virtualization support for the Linux platform. OpenVZ is an OS level tool designed to support Linux platform to create virtual environment for the running VMs under different OSs. OpenVZ is an open source container based virtualization solution built on Linux to support virtualization and isolation of various subsystems, limited resource management and checkpointing. OpenVZ modifies the Linux kernel. Several VPSs can run simultaneously on a physical machine. These VPSs look normal Linux server. Each VPS has its own files, user and groups, process trees, virtual network, virtual devices and IPC through semaphore and messages. The resource management subsystem of OpenVZ consists of three components: two-level disk allocation, two-level CPU scheduler and resource controller. The amount of disk space a VM can use is set by the OpenVZ administrator. The first level of disk allocation. So each VM acts as a standard Linux system. Hence, the VM administrator is responsible for allocating disk space for each user. So this is the second level disk quota. The first level CPU scheduler of OpenVZ decides which VM to give the time slice to, taking into account the virtual CPU priority and limit setting. The second level CPU scheduler is the same as that of Linux. So therefore, the resources that VM can use are well controlled. It supports checkpointing and live migration. That is a special feature of cloud computing. The complete stage of VM can be quickly saved to your disk file. This file can be transferred to another physical machine and VM can be restored. So it only takes few seconds to complete the whole process. However, there is still a delay in processing because the established network connections are also migrated. So how the typical cloud will look like? You see the hardware, hypervisor, and you can have any number of machines, virtual machine 1, 2, 3 and so on. So typical server virtualization deployment, hardware as a hypervisor, management, so OS, guest OS, and above that you will be having whatever may be the platform. You can have the whatever may be the platform or the flavors of Linux. You can have the app. Typical VDI deployment, desktop, operating system and hardware. You can have the three clients. Security issues, hypervisor is the underlying component of all this. So scale of deployment is it's one of the major issue. Here comes the security issues. Isolation, machines of a company and competitor be running on the same machine. So new API to access virtualization or cloud services is needed. Sample hypervisors are given as CVE 2007-491. So many number of hypervisor. So the guest operating system buffer overflow and arbitrary. So over each and every hypervisor will have its own escalation. Security issues. So hypervisors are written by the human. They have buffer overflows. So complex. When the code is long, it will be complex. Thank you.